Hello, this is Ryan Joos and Carissa Lawrence, and we are here to present to you our CIT 260 midterm project, Escape.
Escape is a thrilling role-playing game where the user's character is shipwrecked on an island. The player has to gather the resources to build a raft and escape the island.
The first thing we're going to talk about is the three functional layers in developing a Java program. The first layer is called the view layer. Now the view layer, if you're going to compare it to a human body, is going to be like the ears, the mouth, or the hands, or something that a user can interact with. Examples of this could be like the Get Help menu, a map, or something that's trying to prompt you to receive information from you like your name. The next layer is the model layer.
The model layer represents all the logical or real-life data, and it regulates how this data can be accessed and updated.
The next layer is the control layer, and if we're going to compare this once again to a human body, the control layer would be like the brain. It's where it does the different calculations, goes through and execute functions and commands, and does everything like that.
Attributes, methods, object instances, and classes are essential parts of creating a Java program. Attributes are all the class instance variables created in the model layer. The attributes value define the characteristics of the class objects. They are private, but they have public getter and setter accessor functions. In Java, functions are referred to as methods. A method consists of statements or commands used by an object of a class type to perform an operation. All of the methods should follow the central theme of the class.
Objects in Java contain the important nouns of the program. They're constructed from the class definitions. An object instance contains its own unique values for an object. For example, the dog will have its own instances, such as a breed and gender. So instances are specific examples of the different classes. Also, there's Java class. A class describes a group of objects of all the same type. They have a single theme, has a name, contains a set of computer instructions that define the attributes or characteristics and functions or behaviors for all the objects of the same type.
This is one of our UML diagrams for our project. In the resource class, we have attributes that are private, as you can see with the minus sign, and its getters and setters below it. In the resource control class, you have the different methods, such as get inventory, gather resources, and those are public. There is a dependency relationship between items and resources. The items use the resources. That's why the arrow is pointing towards resources. This is because resources such as wood are needed to build tools. There is a cardinality between raft and game. There can be 0 to many games, but there's only one raft per game. There is also an association relationship, because the game has one raft, or in other words, it shows that the game owns one raft.
Here in the UML diagram, we can look at some of the different classes and certain things about them. Here this map has two attributes called row count and column count. This diagram also shows relationships, so we have dependency and association relationships. In the map control, we have different methods that we're going to use later, such as move and observe location. These are just the things that we want this to be able to do in the future. For example, location has a dependency relationship upon map to be able to get its meaning. In this diagram, we can talk about cardinality. For example, every game has only one map, but the map can be used in many games.
Here is the implementation of the raft class in the UML diagram to actual code in the model layer. We created a Java Bean class by first implementing the serializable interface. This is important because it allows the Java Bean to be formatted so it can be stored on a disk or passed across a network. Next, we create a default constructor. This constructor is used when a new object instance for the raft class is created. Lastly, we create private class instant variables, such as raft status and description, along with their getters and setters, so that they can be accessed outside the Java Bean class. The methods hashcode, equals, and toString can be useful for debugging and creating a more efficient program. The way to put these into the program is by clicking Source in NetBeans and then inserting the code. This can also be used to create constructors and getters and setters.
We had to make several Java beans. An example of this would be the map Java bean that we created. To be able to make it a Java bean, we first did the implement serializable. Then after that, we did the private class instances. We made a default constructor, set getters and setters. And then to finish it off, we did a toString, hashcode, and equals. For this example, the scope of this variable, string select game, is within this block of code. It can be used inside of here. And the lifespan of it is, this is its birth, congratulations, a beautiful string is born, and the death is this curly brace down here at the end, saying that this function is over.
Now we are going to demonstrate how arguments are passed into functions. In the running speed view, you have the getTimeInput function and the getDistanceInput function. These both prompt the user for input and then are returned as double values. Looking at the getReturnSpeed function, it uses the arguments input time value and input distant value. Notice that they are both doubles and the data type should remain constant throughout the passing of arguments. When you call the calculate running speed from the map control, it passes by reference the input time value and the input distance value. This is essentially passing the values location so that they can be used in the map control to do the calculations.
In this section, we're going to be talking about functions and passing arguments into the parameters. In this one, we have calc bridge size, and we have 3 different variables to be put into it. We have room reserved for a double length, double width, and a double height. Now to be able to pass it in, I'm going to come over here to crossriverview.java, and here I have private view build bridge, and this method is going to pop these values into that method over on the mapcontrol.java. So to be able to do so, mapcontrol.calcBridgeSize, they'll call that function and pass into it these 3 different values. Now we're going to talk about primitive data types, mathematical operators, and relational operators. For my example of a primitive data type, I'm going to come down here to double bridge volume. So a primitive data type is an example of a variable, and it could be the different types of variables that you can have. For example, double, integer, string, etc. Now in here we also have some mathematical operators. In here we have the multiplication symbol. This would times all these together, and then that would equal bridge volume. For a relational operator either defines or compares 2 different entities. For this example, we have player's name and then is checking to see if it equals null.
As stated earlier, primitive data types are just the most basic data types of Java. So here are some few examples. We have a char selection and a Boolean valid. In calculate running speed function, we have examples of both mathematical and relational operators. Here is a relational operator where time is compared to be less than 15. Down here, a mathematical operator can be simply a divide that divides time divided by 60. Now we're going to talk about the different statements in Java. Here's an example of an if-then statement. If the requirements are met within this if statement, the time is less than 15 or the time is greater than 45, it will complete the commands inside the block, which means that it will turn -1 and report an error. If it doesn't meet these commands, it'll skip over this block and go to the next code. Here is an if then else statement. If it meets these requirements, then it will perform the command of asking the user to enter a new file and then continue back to the beginning of the loop. However, if it doesn't meet it, it will skip the if and perform the else, which saves the file into the save game. Here is an example of an if, then, else, if ladder, which is great if you have lots of options to choose from. In the first if statement, if the amount is less than 1, then the raft status will just be returned to provide 0%. Else if you have another option to choose from, where the amount is less than or equal to 10 and the amount is greater than 0, then the raft status will be 20%, and it will continue down on to choose from options all the way up to 100%. Now we have a switch statement. If the user's input matches one of these cases, such as the user input C, then it will perform the commands within the switch statement and then stop at the break. If none of these cases are met, it will go straight to the default and tell it that it is an invalid selection. Then it will go to the default and tell the user that it is an invalid selection. Okay.
Here's an example of an if statement here in my Java program. In calc bridge size, it's checking to make sure that these certain variables are meeting certain requirements. So for this if statement, it's checking to make sure that the length is between 10 and 15. If that's the case, then it'll skip over to the next one. If not, it'll return -1 and say that there's an error. In this one, we have an if then else statement here. So in here, it's saying that if this is in this example, if the select game.length is greater than 1, then it'll continue. If not, it'll just restart the loop over again until the correct values are inputted. Here we have a good example of a switch. We have different examples for the user to be able to choose from. If they select C, then it'll implement this, and it'll break the loop. If they select B, then this will happen, and L, this will happen. Now we're going to be talking about while and do while statements. In this example, we have one of each right next to each other, which is very convenient. What they're all about is they create loops, and these loops will continue until certain conditions are met or not met. For example, once these conditions are met, it'll break it and then return input value up into the function. Here for the do while statement, it's pretty much the exact kind of same thing, but it'll continue to do something until while the selection does not equal L. Once that condition is met, it'll break the loop and move on to something else.
The obstacle volcano view has more examples of do while and while loops. Here is a do while loop. It'll first do these commands before entering the while loop. While the selection is not equal to yes, it will continually repeat the do while loop. If selection is S, then it will stop the loop. Down here we have a while loop. If the condition is not met inside here, then it will continually repeat the while loop. If it is valid, then it will stop the while loop and return the input value.
Lastly, we're going to talk about JUnit tests. Now we've created this lovely function under map control called calc bridge size. And we want to make sure that all these conditions are being met and that they're working properly, that if the logic in here is not being met, that it'll return -1, and that the conditions will to let us know that there's an error and it's not working properly. So to be able to do so, we come over here to map control, we right click it and then go test file. That will create one of these. This is one of the JUnit things, and here it is for test bridge raft size here. And so we have some hypothetical values that we've passed into it, and the only thing it needs to do is check to make sure that the calculations that we expect are happening and that it's operating correctly. So this is just saying, oh, this condition isn't being met here, so return -1 and let us know that there's an error in this. And so that's a JUnit.
We have another test package for raft control. This uses 7 different test cases. The first one tests if the user inputs valid information. The next test cases test to input if the user inputs any bad information, such as negative values for height. The last 2 cases, test case 6 and 7, test the boundaries of our variables. Essentially, test packages are just used to make sure our function can handle whatever input the user is inputting. To do this, you right-click on the test package and select Test File. It shows 100% because that means that our function was able to pass all of the tests.